But since there is some rotation, the dynamics is a bit more interesting. So I have my frame. This was E1 rotates to some frame here. This is the angle theta. B1, body axis. E3 rotates to B3. Again, it's the same angle. What about B2? Yeah, so it's equal to E2, right? Because the rotation is about. Okay? So the problem asks us, you remember this problem, we solved this problem exactly before, but it was maybe point mass or just a slender rod. Point mass, I guess. Now we're making it a rigid body, and we're making it a bit complicated. It's just composed of two thin rods, to make the eye a bit complicated. Okay, so this rigid body is doing pure rotation motion. It's kinetic energy. You can do it this way, of course, but it's a bit harder. Let's do it that way. The objective actually of this problem is to make some training with you on how to compute this term. Because we did this several times. 1/2 mv square, we did it several times. We need to compute 1/2 omega transpose I omega, and so we need to get omega, and we need to get I about the O point. Anybody doesn't understand the problem first before proceeding with the math? If you have a question, yes, Joseph?
Is it a pinned joint at O?
Yes, it allows rotation theta.
But only on one axis.
Yes. Was the question you?
Can you explain what the mass, how the mass 2m to L corresponds?
This rod, it's a T shape.
Oh.
This rod, its mass is 2m, its length is 2l. This guy, which is welded here, has a mass m and length l.
Okay.
So it's a composed body. Yes, Ken?
It's a T-shape, but it's not like it is rotating in a bar. So it's T-shape.
No. Yeah, it's just like this guy hanging down, but has this funky shape. That's it. Okay.
It's a hammer sort of a thing.
Okay, let's compute the omega and the I and do this very simple calculation. Okay. So what's omega? What's omega? Should
Theta.
be experts on this now. I have two rotations. What's the first rotation?
Theta.
It's omega about what axis? N3. And then the second rotation? Theta dot about what axis? Yeah, it's E2, B2, or minus of it. We gotta fix the sign later, so it's E2 or B2, right? And actually this guy N3 or E3. What about the sign here? This was positive about N3. What about the sign there? It's minus. Okay, this equation is based, either of these equations are based on the fact that I will be written in the body axis, because it's much easier to write it in the body axis, and accordingly omega has to be written in the body axis. So this term is already in the body axis, because it's B2, I have to write down this guy in the body axis. So, like I said, you're expert on this in the following sense. This is 0 negative theta dot 0, right? This second term. The first term is 0, 0 omega, but this is in the E frame. I want to go from the E frame to the body frame. From the E frame, the red frame, to the body frame. So this is, I need to multiply by a single rotation matrix. It's rotation by an angle what? Theta, about what axis? Second axis. Please, it's negative theta or negative the second axis. Take the negative into account, right? Any question about that? And you know how to construct this very easily. It's about the second axis, so it's 0, 1, 0, 0, 0. Typically, if it's the second axis, it's cosine, negative sine, sine, cosine, right? That's correct. But please put negative theta inside. Cosine negative theta is the same as cosine theta. And then sine negative theta gives you another negative. So it's confusing, but it's good. Train yourself. Do you have any question about that? Okay, so we got the omega easily. This is omega sine, omega cosine, and negative theta dot. So here is your omega vector. It's not that hard. I just need the I matrix now. Okay? Any question about the omega vector, please? Any question about the omega vector? The I, in order not to confuse yourself, we write down I in the body axis. So please do it in the body axis. We have here this guy. This is what we called B3. And this is B1, right? In the body axis. This is 2M and 2L length. Maybe I'll do it with another color. And this is M and L. Any question about this picture? You laugh sometimes, all right. Any question about this picture? Any question, please? So, my I inertia matrix is two terms. One for the red and one for the green. It's as simple as this, right? Any question about that?
Do we add them at the end?
Yeah, we add them. Simply add them. Any question about that? Okay, let's get the red one, please. I'll give you some time to write. Just watch me how to construct the matrix, because we do it very easily. It's always ml squared over 12. The mass of the red guy is 2m actually. Its length is 2l. So I substitute in the formula. ml squared over 12, correct? And it's diagonal matrix, so this is all zeros. I just need the numbers of the diagonals. There are always a couple of ones and 1 0. Where is the 0? 0 along the axis that is aligned with the rod. This is the rod. The axis aligned with the rod is the 3. So the third component is 0 and have 1 0. Okay? What about the green one? Let's do it for the green one. Again, it's ml squared over 12. The mass of this guy is simply m. Its length is simply l. So l squared. Now, again, it's diagonal matrix. I just need the numbers of the diagonal. Where is the 0? The 0 along the axis that is aligned with the rod. This is the axis aligned with the rod. It's the one axis, B1. So this is 0, 1, 1. Any question about that so far? Any question about
It's
that?
about the center, right?
Yes, I'm going to discuss it in a minute. But any question about constructing these two matrices? I mean, this is very trivial example, I know, but I am careful that you guys solve problems as well as understanding the very deep concepts. You have to know how to solve problems. Any question? Okay, like Ashkan was saying, remember that this is about the center of mass of each individual. So this is I about this point for the red guy, and I about that point for the green guy. We need to use the parallel axis theory. We need to transfer I. This is again easy. You need to add another matrix here and another matrix there. Adding the matrix here, the rule says it's simply the mass of the guy, which is 2m, times 2 matrices multiplying together. And the same here, adding the mass of the guy times 2 matrices multiplying it together. And as expected, these two matrices should have some information about, okay, where do you want your I, final I want about the point O, please. And where was your initial I? It was about this red point. So we need to transfer along this position vector, okay? So write down this position vector, please. Write it down. What's that? This position, little position vector. It's the distance L along the B3 axis. And I don't care from where to where. So I don't care if it's L along B3 or negative B3. I don't care. Because it will be squared. Then take this vector. It's 0, 0, L, right? Construct a skew-symmetric matrix out of that. You know the skew-symmetric matrix? It's the other way now. It's zeros over the diagonal, negative the third component, the second component, negative the first. And then you continue by skew-symmetry. Let's do it here. From here to there, my R is 2L in the B3. Construct the skew-symmetric matrix out of that, please. So it's zeros over the diagonal, it's the other way around. Negative the third component, the second, negative the first. And then continue by skew-symmetry. So this is the negative of that. Okay? Then the other matrix is simply the negative of the first. This is very easy. That's okay. So I will just make L, negative L, and that's it. And here is 2L and negative 2L. Okay? Do all these matrix multiplications, you get your I as ml squared over 12. If I remember correctly, this was 80, 81, 1. And it's a diagonal matrix. Any question about that? Any question, please? Yes, you.
Can you explain how the green body is 2L by?
The distance from its own center of mass to the point that I want is 2L.
Oh, okay.
Any question? Yeah, I want to finish this.